Hello guys, today we will discuss about a temperature rise in a electrical system. System can be either a motor or a small electronics device like a watch or a mobile. So temperature rise is an unwanted phenomena that is happening to the electrical system unless you are designing a electrical heater. So why temperature rise is happening? First we have to understand, when you try to apply electrical energy into the system trying to get a desired output, let's take it is a motor, your electrical energy getting converted into equivalent of mechanical energy. While it is getting converted, you can't get a 100% efficiency. This is not going to happen. You will have some 99% efficiency. Let's say you have designed a best system, so that is producing a 99% efficiency. But why not that 1% efficiency is not able to meet? So when you take out any system with a resistance in it, it will going to develop a heat. So when you are applying a electrical energy, that is going to convert it into mechanical energy plus heat energy. We have to figure out why the heat is happening. So you have a motor that is connecting to the AC source. You are applying a 100 watt and 99 watt is used for mechanical energy, but that 1 watt is getting dissipated as a heat. So we can write 100 watt electrical energy transferred into 99 watt of equivalent mechanical energy plus 1 watt of heat energy. So this 1 watt is your heat energy. When you have an energy, it will be used to produce some work. When you have a electrical energy, it is used to produce a mechanical output. So the same way, heat energy going to produce some work, that is going to be your temperature rise. So heat energy going to produce a temperature rise, but we have to figure out how much the temperature rise going to be. So let's take a one element. It has a mass of 1 kg. Let's say it has a mass of 1 kg. This is going to be aluminium. Let's consider this is going to be aluminium. You are applying a electrical energy. So this, okay, let's take aluminium at 20 degree Celsius at the initial. You are applying a heat energy. This heat energy will heat the aluminium from a 20 degree to X degree. This X degree is always going to be above than 20 degree or a beginning temperature. So we can form the equation from this. So heat energy equal to heating from a one temperature to another temperature, that is going to be your delta T times mass, delta T times mass. What else we have to consider? And a constant for a particular element. So why this particular constant is coming? So when you notice any system or any element, you have a different material and not all the material heats up at the same time because of the molecular structure. Aluminium has a CP, specific heat capacity of 0.89 kilojoule per gram. The same way you can calculate, same way you can identify the specific heat for any other element or any other atom or any other structure. Even water has some specific heat. If you wanted to heat water from 0 degree to 100 degree, you are applying a electrical energy, you are turning on the stove. That has some mass, water has some mass. So we can say you are applying a thermal energy that is going to be heating your water from 0 to 20. That is going to be your delta T. And how much amount of water? If you wanted to heat a small amount of water, it will be heated very easily. If you wanted to heat like a barrel, it's going to take a more time. So you need to consider a mass. And also even water has a specific heat constant. This is a specific heat constant. So you understand how the where the heat is coming from, why the heat energy is getting developed in your system, and also temperature rise is also going to be happened due to that particular electrical energy. So let's try to understand from a real life perspective. Let's say your bus bar or a mobile starting at a ambient temperature 40 degree, and you have a standard saying that it needs to be stay well within limits of 70 degree because of a safety reason, because nobody want to burn up the hand with the heated system. So basically you are restricting your temperature rise to 30 degree. 30 degree is going to be your delta T. So you have a delta T in your place, that is going to be 30 degree, and you need to know how much mass you need to have to restrict your temperature rise going beyond 70 degree. So you are using a aluminum as a material, and what else? You have a wattage of 62.72 watt. That is what happening in your system. So you have to either develop a heat sink so that it won't never reach a 30 degree temperature rise, or else you have to use a cooling system. So your heat is going to be Cp, M, and delta T. You know delta T, you know Cp, you know how much the watt is going to be. So you can calculate very easily how much mass you need to put. If you put everything into the formula, you will get something like let's try to put 0.89 into 30 and 62.72 into 20. This is going to be your mass in a kilogram. You will get it in a kilogram. So let's say you have a bus bar. You have to add, let's say your mass is going to be X amount. You should ensure that your bus bar mass is always higher than this X value or equal to the X value in order to maintain 40 degree to 70 degree. So you put a temperature rise of 30 degree, so it with this same mass you never going to go beyond a 70 degree. So if your temperature rise just need to be in a 60 degree, you can put a delta T as a 20 degree Celsius. You can calculate from that. So for example, you don't have a delta T, you just wanted to know how much your system going to be. Let's say you are having a 100 watt that is developed in your system. that is a heat energy, and you are starting with a temperature starting with a 20 degree, and you wanted to understand what is the temperature at the last, that you have to figure out. You have a specific heat capacity for a particular element, let's say aluminum 0.89 kilojoule per gram, and what else you need, and your bus bar is like a 1 kilogram. From that you can easily calculate how much the last temperature going to be. Let's try to do that. So 10 watt equal to temperature last minus 20 degree into what is mass 1, what is Cp 0.89. so when you put everything except TL, you rearrange the equation, so you will get what is your temperature last. So with this same formula you can either calculate bus bar, or you can predict how much your system going to be. It is very as simple as that. So we have understood from the formula how much temperature it's going to rise, and how much mass your system need to have in order to have a particular temperature rise. So let's try to see from an engineering perspective what are the options you can do. Either you can use a cooling system if you have so much money, and the second thing is you can, let's say you have a bus bar. I just told you from a heat energy is equal to mCp delta T. For a particular amount of heat, let's say it is going to be constant. For 100 watt, your Cp is going to be constant, and there will be a delta T, there will be a M. So if you wanted to reduce a temperature rise, you have to increase a mass. That is very evident from this equation. So you can say delta T always going to be inversely proportional to temperature rise. So in order to eliminate a temperature rise, what you can do is you can add a more mass to your conducting circuit. So it can be done either with the, you have a bus bar, you just let me grab another pen. You just put a, this is going to be thermal conductive sheet, and non-electrical conductive, and you can connect so much mass so that your temperature rise will be limited, or else you just take a bus bar and connecting to the chassis or your enclosure with this kind of a material. It should be thermally conductive to effectively transfer the heat, and also it should not transfer the electrical energy, so that you won't get shocked from the enclosure. So these are all the two ways you can effectively conduct the heat, and also you can have a better heat transfer efficiency. And never forget to add this sheet. We have discussed about electrical energy and how the electrical energy is transferred as a heat energy, how to eliminate the heat with adding a heat sink via thermally conductive and electrically non-conductive material. So this is going to be your conductive element, this is going to be your that thermal conductive sheet, and this is your chassis. So what is the issue with this kind of a arrangement? So even though this is a electrically non-conductive, you would expect some amount of electrical transfer. So when you try to do insulation resistance test, your insulation resistance value going to be in a 10 mega ohm. If you are okay to have a 10 mega ohm in your system, then you can go for that. This is one of the limitation you are having in this kind of a cooling system. So the second thing is, we have to discuss about the voltage systems. When you ask me whether I'm okay to have with the 10 mega ohm, I will say it's okay to have a 10 mega ohm because I am dealing with a 12 volt. So when you apply a Ohm's law, your resistance is going to be 10 mega ohm and your voltage is going to be 12 volt, and the current never go beyond 100 milliamps. And if your current doesn't have a more than 100 milliamps, it's not going to produce any harmful effect. So this is what happening in your vehicle system as well. So when you ride a bike, you have a 12 volt battery in your bike, and it doesn't have a return path, so they will connecting it to the chassis itself, because you are dealing with only 12 volt system. Even the 12 volt passing across your body has a around a 500 ohm. So 12 volt divided by 500 ohm, it's not going to cause any health issue to your body. That's why in electrical vehicles in terms of a bike, you don't have a higher voltage. So but when you are dealing with a 230 volt, if your human body have a 500, approximately 500 ohms, so you will develop a 0.5 amps. It is going to harmful to your body. So when it's okay to choose a electrical system with a heat sink connecting to the chassis, but you have to be very careful about what kind of a voltage level you are choosing. As long as your voltage system is under a safe limit, you are okay to have a different cooling or a heat elimination system. And also 60 volt is a extra low voltage system. So basically means this 60 volt, if you are using a system that is having a less than a 60 volt, it is fine to use this system. Like your mobile batteries have a 2.2 3.2 volt, like your watches have a 3.2 volt, your bike has a 12 volt. And if any circuit have a less than 60 volt at any given point, you are okay to use this system. And also this extra low voltage not going to cause anything harmful to your body, even you are touching a two line and whole amount of current passing through your body. So that's it, guys. So if you wanted to understand more about the voltage system in deep, please leave a comment. And also if you have any doubt related to electrical or any engineering terms, please leave a comment, so I will try to put a video on that.